Yeah, sir. So we'll start the session, sir.
Sure.
We are live now. I'll just introduce. So, a very good morning to all the participants of the first session of the second day of the 18th Green Cementech 2022 with the theme Preparing for a Net Zero Carbon Future. I welcome our chair for the session, Mr. Vinay Kapil, Group Functional Head, Power Plant, Electrical and Instrumentation for Dalmia Cement Bharat Limited. Mr. Kapil has total 27 years of experience with a demonstrated history of working in the building materials industry. He has immense experience in thermal power plant, waste heat recovery, waste power plant, solar plants, and cement plant project engineering, commissioning, and operations and management. We thank you for accepting our invite, sir, and chairing this session. May I request you to now kindly lead the session, sir? Over to you, sir.
Okay. Thanks, Team CII. A very happy morning to all the speakers and participants. I welcome you all to the 18th Green Cementech virtual conference, wherein in parallel to Green Cementech, today CII is organizing a session focusing on energy efficiency and CPP and WHRS. So in today's session, which is basically 6C, we have a very interesting topic. That is key challenges and alternative fuel firing option in CPPs. Seeing the present fossil fuel prices, or otherwise also seeing the net zero target of our nation, all these make this topic very relevant. As we know, in cement CPP, we generally have AFBC and CFBC boilers, which are basically designed for feeding and firing various kind of fossil fuels, but not green fuel or alternative fuels like biomass, which require large volume in feeding system and also much higher heating surface area due to much lower bulk density of biomass with respect to any fossil fuel. So in general, in CPP, while firing green fuel or alternative fuel, we come across issues like first and foremost, like availability of suitable alternate green fuel in required quantity. Then their cost is issue with respect to fossil fuel. Then consistencies, quality is one major issue we do face. Then appropriate sizing are required for AFDC and CFDC boiler. Then we need to have a certain or appropriate handling and feeding system for such alternative fuels. And then those various alternative fuels or biomass are associated with alkalis and chloride contents, which also we need to check. Otherwise, it affects the boiler reliability. So I hope in this session, various speakers who are basically mix of our CPP experts and OEMs will give us a new perspective to maximize the alternative or green fuel consumption in CPP. Further, government is also encouraging to fire biomass in CPPs, you must be knowing, by various means. Now, biomass consumption in CPP can be used to set off the known solar RPO compliance. And there recently they have given 2.5 multiplier in their recent order. So that will help us CPPs to maximize their biomass or green fuel or alternative fuel consumption. So in today's session, we will be having 3 speakers. And after completion of presentation from all speakers, question and answer will be handled by them in one go. So in this session, first we will have Mr. Nagaraj Prasad, who is from Shanti GD Spath. He at CPP. He will be sharing to us about issues and challenges faced by CPP. So Mr. Nagaraj, welcome. Please share your presentation.
Good morning, sir.
Good morning. Good morning.
Very good afternoon to one at all. And this is myself, Nagaraj Prasad, having the experience in the power sector from the last 12 years. I am leading the power plant which is located in Chhattisgarh, and its capacity is 15 megawatt. And our plant is of consisted with CFBC boiler along with the steam turbine. And CFBC boiler in earlier days, we used to fire with the coals and some amount of biomass fuels. But in present situation, due to the fuel prices and the availability, and we started use the maximize this biomass, which is rices. And I will share my presentation. What are the problems we faced and how we overcome these problems. Can everyone able to see my screen?
Yes.
Yes. Usually what happens when most of the plant which is in operation, which are erected and commissioned long back, mostly 10 years or 15 years back, and recent plants are very less. And 10 years, 15 years back, the fuel scenario and the availability is entirely different from the present situation. And what happens due to the change in fuel, what we faced is the coal availability of the power plant is getting down. So we used to increase the rice gas usage. In our CFBC boiler, when we use the rice gas as a fuel, we face the problem of increasing the cyclone outlet temperature and the reduction of fuel generation because this rice's bulk density is very less and the furnace volume was desired for the coal, and due to this less volume of biomass, then this was fired more in the cyclone outlet chamber. What we did is we reduced the fuel feeding elevation. Earlier, biomass elevation was provided in the elevation of 4.5 meter, and we bring down this elevation to 2.5 meter. And after reducing this fuel feeding elevation, we got some benefits, but still the temperature of the cyclone outlet temperature was gone up to 1050 and 1030, due to which we faced some problem of superheated tube failures, long time overheating. Such failures we faced. Then the availability of cyclone vertex cylinder, that was also very big question for us. Then we are added some evaporator panels in the furnace. What happens in during the design stage, if you want to add whatever the panels, it is very simple. But once after the plant get into the line, adding the evaporator panel needs more modification and downcomers and the risers to enable the proper circulation. And we added this evaporator panel in the furnace as like a wing wall superheater. Then we modified our downcomers and risers. This is the view of our power plant boiler. The location in parallel to this wing wall superheater, we added this evaporator panel of 3 numbers. After which, adding this evaporator panel, we have got of such a benefit of reduction in cyclone temperature. But what happens this as we fire more biomass having the less ash percentage, CFBC boilers need some more ash circulation in the system so that the steam generation will also be in line and this furnace operating parameters will become normal. So we reduce the cyclone inlet opening to increase this velocity of the cyclone. Earlier it was the cyclone inlet velocity is 20 meter per second. We increase the cyclone inlet velocity up to 25 by reducing this cyclone inlet opening of 1000 mm to 750 mm. After which we got such a good observation, and collection efficiency also got increased. But what happens after increasing this cyclone velocity, we got a benefit in collection. But again, the problem we faced is erosion in this cyclone refractories. We earlier people supplied with this low Siemens castables, but wherever we face the erosion, we completely remove this refractory and we gone with the plastic refractory. After which that is also came down, but still the erosion level is there after using this plastic refractory also. In the point of this combustion profile, after using of this biomass, this temperature profile in the furnace was entirely different as compared with the coal. When we fire the coal, the bed temperature between the bottom and the furnace top temperature was very less. It is of around 30 to 40 degrees Celsius. When we fire a more husk, it completely burned the top of the furnace. So bed temperature is become much difference between the top temperature and bottom temperature. It was around 100 to 120 degrees Celsius. But after modifying this cyclone, again it was reduced between the 70 to 80 degrees Celsius, but still the temperature difference is there. Sometimes what happens, the cyclone gets choked due to this biomass bulk density. When the bulk density is less, there will be the issue in the cyclone flowability. The collected ashes will not properly flow back to the furnace. Early once or twice we faced the cyclone choking problem whenever we fire the husk more than 70%. Then we discussed and we added some cyclone purging arrangement like air blaster in the furnace where people used to do give in the ABC boilers. That air blasters we provided in the cyclone cone area. Then afterwards that will also came down, but still choking used to happen early once or twice. This type of the tube superheater overheating failures faced in the superheater zone. This earlier the LT superheater outlet material was T11 material, and we calculated this metal working temperature as it is crosses 510 or 520 degrees Celsius. We changed this superheater only this outlet tubes with this T22, and it was changed in the last 1 year back, but after which we didn't face any problems. But unfortunately, the earlier materials also 6 or 7 years of operation, but also we are waiting for the term after 6 or 7 years operation, what will the result for that? And the possibility of co-firing of biomass with the fuel. What happens? Points to be taken care when we fire the high moisture biomass like bagasse or high moisture husk. You need to consider as the sulfur should not be there with the co-firing fuels. If it is sulfur is more, then there will be a more possibility for corrosion in the downstream, like air preheater and economizer inlet water cold zone. There will be a possibility of more corrosion. Then when possibility for looking for the low co-firing of coal with the multiple coals or biomass, you should to consider about this fusion temperature, because this many fuels which is coming from this foreign or imported or in Australian coal and Indonesian coal, their fusion temperature used to less. When plant boiler is designed for as Indian coal, which ash fusion temperature is more than 150 Celsius, we when we use this imported coal, there is a possibility of ash fusion in this superheater zone, because this temperature is in much high in this ABC furnace. So there is a most possibility for ash fusion. That is also to be taken care. If you want to use the low fusion temperature, definitely you need to add more evaporator panels so that the superheater temperature, gas temperature will be in control. And if you want one more thing, high ash fuels along with this biomass is much better, because this high ash fuels used to capture this moisture which is available in this biomass, so that this corrosion and fouling problems will become less. That's all, sir.
Yeah. Thanks, Nagraj, for sharing your experience on various issues that you have faced while firing biomass in your CFBC boiler. And you have explained in details how you have overcome those problems one by one, and you could optimize your biomass consumption. I hope whatever you have shared, it will be useful to all the participants here. Thank you, Nagraj.
Thank you, sir.
Yeah. So now in today's session, the second speaker, we have Mr. Sachin Mane. He is from Thermex Limited, and he will be sharing about decarbonizing through energy efficiency measure using the ESCO model. So welcome, Mr. Sachin. Please share your views, your presentation.
Yeah, thanks, Vinay. Good morning, all. Am I audible?
Yes.
Yeah. And morning, all. I'm just sharing my screen. my screen is visible, sir?
Yes, okay.
Yeah?
Yes, it is visible.
Yeah. Thanks. So as the topic says, this is all about our newly created business vertical called Energy Management Solutions. Though the overall, panel is related to CPP improvements and challenges related to CPP, I'm going to cover a little more broader aspect of overall energy impact and the entire cement industry and the targets in front of them today to reduce overall carbon footprint as well as becoming more and more competitive in the nature. In line to that, I'm going to cover little broader aspect of overall energy management, and I'm not going to restrict my presentation only to CPP. As this is going to be a newly created business vertical, it is equally important for cement industry to understand how and what way we are going to create that and work with all the cement manufacturer, whether it is an integrated cement plant or a grinding unit, as an energy partner. So for a people who might have joined from abroad, I just wanted to give this single slide representation which talks about overall Thermax. We are more than 55 years old company. So the experience we are gathering for more than 50 odd years is converted into an Indian multinational which has its own presence into majority of the Europe, US, Southeast Asia, Middle East, and of course the home ground in India itself. We have multiple manufacturing facilities which are outside India also, though our majority setup lies within India, but we are truly from a manufacturing point of view, from an offices point of view, from a clientele point of view, today we are representing Thermax brand in more than 86 countries. So from all these perspective, just a one slide representation, how we are taking care of global requirement of all the products which are coming under energy, environment, and chemical. Another way of representing Thermax overall, business structure. If you see the left portion, which is our OEM expertise, which talks about our manufacturing capability, right from a baby boiler to a power plant and even to a super thermal, supercritical zone boilers. Whether it is a process heating requirement, whether it is a utility range requirement, we have our own businesses which are taking care of this requirement in the marketplace. We also treat waste which is coming out of all the industries, whether it is in form of liquid or it is in the form of gas. So we have waste water and wastewater treatment division. We have air pollution control division. We also have industrial grade cooling applications where we are supplying our thermally activated vapor absorption machine, then closed loop cooling tower, evaporative condenser. And of course, as I mentioned, there is an entirely different business vertical where we are producing variety of chemicals which are required as an fireside chemical. There are chemicals which goes into water treatment. So there are range of products which are available under chemical basket. Apart from that, keeping eye on the changing energy demand, we are also working on multiple initiatives through our research wing, whether it is a carbon capture, whether it is a green hydrogen, whether it is a gasification, whether it is a bio CNG. Of course, we are having good experience in solar, but we have also entered recently into a development mode as well under a newly formed subsidiary called First Energy Private Limited. And whenever there is a typically cement plant or a metal industry where there is also a demand for captive power plant, cogeneration power plant, we have more than 115 executed projects. So we have a capability, a very large engineering and project execution capability, where we have supplied more than 115 complete EPC project, including the civil. And there are multiple ongoing projects because of the drive, a major drive in 2G ethanol, or I'll say overall CBG, that is a compressed biogas coming out of the digester zone. So there are multiple ongoing projects under the EPC capability. Renewable, I just spoke. We used to be known in the industry for rooftop solar installation, but we have created an entirely different subsidiary for which we will be putting a lot of money and going to have a lot of investment, which will ultimately yield ground mounted multiple megawatt related solar power plants. And currently we as an energy management division, we are part of the power O&M, So we also manage the assets, whether it is a power plant, whether it is a utilities in a process industry, all put together. Today we are managing almost 5,000 crore worth customer assets and round the clock 24/7, and there are predefined KPIs, whether it is a productivity improvement, uptime guarantee of the thermal power plant or the utilities we are taking care, or even energy efficiency improvement. As I mentioned, keeping the eye on the overall energy transition, we have multiple global level tie-ups and JVs by which we are not only bringing best of the best technology to the world, but also we are trying to be ahead of the market. As we all know the importance of digital world, most of our OEM product, whether it is a chiller, boiler, heater, most of them comes with its own machine mounted remote performance monitoring system, which is a nothing but very close to industry 4.0 classified tool, where we can not only see the performance of these assets but also provide meaningful predictive practices and the suggestions to the user so that they can avoid non-avoidable circumstances and avoid the accidents or the stoppages. So when it comes to energy efficiency and the transition, we realize there are multiple business verticals which are existing in nature, but there is not a single vertical which talks about end-to-end energy reduction of the client. Of course, most of our product, whether it is a boiler, whether it is a heater or chiller or air pollution equipment, they are almost at the top of the industry norms. And we are definitely improving those products from an energy perspective also, as well as keeping the CO2 reduction in mind. But when it comes to industry, whether it is a metal, cement, or any chemical or any other industry, is there any vertical which is taking care of overall energy demand and the transition phase of the industry? The answer came out clearly no. That is how we have decided and created this EMS business, where our own expertise of the OEM as well as the EPC expertise integrated with the solar, we felt of bringing this all under one umbrella and willing to communicate to the industry how effectively we can work with the industry as an energy partner and reduce their overall energy demand and optimize on their energy consumption. Simultaneously, through our O&M wing, we can also ensure that your assets are taken care very well, and the uptime guarantees as well as energy reductions are our predefined KPIs. That is how the EMS division has been formed. We covered this we all know the strength of Thermax, whether all utilities, whatever utilities are required to operate a plant and whatever wastage coming out of the plant, both sides, utilities as well as wastage side, both sides we have a businesses, existing businesses. Just to give you example, more than 15 cement plant we are managing today under our O&M. So entire power plant at these 15 odd places we are managing, not only in country, India, even for Middle East and African continent as well. More than 90 waste heat recovery boilers has been supplied, and majority of them definitely goes to the cement kiln recovery as well. Yeah, this is we all know why EMS is so important today, because definitely we are talking about technologies, the fuel shift, or carbon capture methodologies, but these technologies are not mature enough today. Those are at its initial stage, and hence it is equally important for entire industry that how they can further reduce their CO2 even with the existing asset, even with the existing fuel, just by ensuring that you are reducing your energy consumption for the same tons of cement output. And that is exactly where Thermax EMS division is going to help you. So we are not restricting, as an EMS division, we are not restricting ourselves only up to the generation of the power or a steam at the thermal power plant, but we are also willing to communicate and willing to take guarantees for transferring this power, whether it is a process heat, whether it is a chilled water, whether it is a compressed air, whether it is a electricity, all these, right from generation side, distribution side within the plant, as well as consumption area, we are willing to take guarantee, because every area there is an opportunity to save energy, and whatever energy we will save, ultimately it is going to save your CO2. And while doing this, we are also having a very unique solution, which is digital in form, that itself ensures that your variability of the production, whether it is a kiln operation, whether it is a grinding operation, whether it is a cement mill, whether it is a coal, every part of your cement mill. Through digital solution itself, first we will baseline your current processes, current assets, and not only baseline, we will also define the golden batch or the best possible output which has been produced by these assets or the processes. And on a continuous real-time basis, we will compare it. And once we compare it, we also know where is, where is the devil actually. Devil, we all say devil is always in the details. So once we start monitoring this real-time data, we also know exactly where is the deviation. And once we know the deviation, we are going to come forward and give you guaranteed saving plan, that how we are going to reduce this deviation from an energy perspective as well as from your production perspective, or even from an uptime guarantee point of view. And while guaranteeing this, we are also having a very unique commercial model available, that is the ESCO. So for a specific application, for a specific area, whether it is a Thermax product or outside Thermax product, whether it is technology which is not known to Thermax, but we have hired a lot of expertise related to cement industry. I'll cover it in subsequent slide. But the point I'm making here is we are also willing to invest in your premises and going to take our investment back in a form of saving model itself. So whatever amount we are going to save through this energy efficiency idea, we will decide upfront how much percentage is going to be taken by Thermax and how much percentage will remain with client. So that's a unique proposition as an ESCO at an entire plant level, not at a utility level or only at a boiler level. So there is a thematic approach. This slide covers what all utilities we are going to take care. And this is not only for a cement industry. This is how Thermax is penetrating EMS concept inside the industry, whether it is a metal, whether it is a pharma, whether it is a chemical or cement. We are talking about improvement of your existing power plant. So there are multiple levers, whether it is a station heat rate improvement, whether it is enhancement of your existing boiler surface area because of the higher capacity or the modified capacity of your kiln, or whether it is improvement in your overall turbine heat rate. We have a lot of types. We are taking this approach of energy efficiency as a service under EPC wing. The way we are establishing power plant where the turbine can be from Siemens or other make, or civil also is going to be taken care by Thermax. Similar way, when it comes to overall energy efficiency, we are not restricting solutions which are only related to Thermax product or Thermax known technologies, but we are going ahead and covering entire spectrum of utilities, whether it is a compressed air, whether it is an electrical system, whether it is a chilled water, which can also get generated from the kiln itself. Today, the kiln has a lot of radiation, which we can convert it into a useful heat where hot water can be used to operate a vapor absorption machine, which will take care of your cooling requirement of control room or a DCS room. Similar way, we also have, because there is another discussion where Exatech is going to present their digital solutions specifically for the kiln operation. So all these people we are bringing together as a single point contact. Under Thermax, we are able to engage with all these solution providers at an OEM level, like whether it is a turbine, whether it is a PH section, whether it is a cooler replacement, all that we are ready to take care under Thermax EMS and willing to give this as a guaranteed saving plan. So with our own experience of managing 15-17 cement client under O&M, and as I mentioned a few minutes back, we also were having and even continuously having performance improvement projects as one of the KPIs at the cement industry. And this couple of verticals, the columns, indicates that how eventually we have improved existing plant heat rate, how we are able to increase the overall availability of the power plant, how we are able to reduce the auxiliary consumption, overall auxiliary power consumption of the thermal power plant. And while doing this, how ultimately it is going to help client to reduce their CO2. And even by having very specifically dedicated and training institute, which is related to our O&M, we know how minimum people can manage all this. Not only manage, even ensure that there is a heat rate improvement, there is auxiliary power consumption reduction, uptime guarantees are there. This is our old experience of O&M, and we are continuing with that as an O&M independent business. But taking this ahead, we are also willing to give this experience for other utilities also, whether it is a compressed air, whether it is a turbine, whether it is a core cement industry. These slides indicate the known solution, which most of you are already in touch with the OEMs, whether it is a replacement of your old 4-stage PH section to preheater to maybe 5-stage or 6-stage, whether it is a AFR incorporation into the existing kiln, whether few trials where you are also trying to put biomass inside your kiln. And because of that, whatever variation is happening, ultimately it is going to hit your productivity as well as the subsequent power generation through waste heat recovery. So all these solutions we are trying to bring under one umbrella. These are related to power cycle. Similar way, when it comes to a cooler replacement, where it is going to be a recirculation of your cooler exhaust and ensuring that you are also generating more power from the existing setup. And while doing this, if we see there is a potential, but your heat transfer area of your existing boiler is not sufficient, whether it is supplied by Thermax or some other make, we are there to support you and give you assured return guarantee. And we are also going to take care of other assets other than Thermax. When it comes to grinding mill, we also are talking about ceramic balls. We are going to take overall responsibility of power consumption reduction in your overall cement mill. When it comes to other auxiliaries in the cement industry, whether it is a blower, whether it is a VFD, whether it is going to be a old IE2 motor, we also have a definite program where we can replace your old and non-efficient or less efficient IE2 motors with IE4, IE5 motors. And wherever applicable, we are also going to incorporate VFDs. And I mean, again, I'm mentioning everything comes as a single window approach. So overall, we are here to help you to reduce your heat content required to produce a clinker, as well as to reduce your overall power consumption per ton of cement. And wherever required, we are willing to work with the OEMs, and wherever we are keen and the client is also keen, we are ready to put our own money under ESCO model. How we are going to do this? As I mentioned, the baselining is very critical, and that is where my investment in one very promising digital industry, digital company is coming very helpful, because they are very strong background, people from IITs, IIMs. They have very unique solution which can be readily deployable. Just within weeks time, the solution can be implemented in your facility. We will be collecting data from your existing DCS, and the data can be interpreted in a very different way. The way client wanted, maybe CMO or a MD level dashboards can be created, operating level dashboards can be created, working level dashboards can be created. I know there are different ways of putting MIS in the cement industry, which has a unique, it has its own benefits. But when it comes to compare your one cement plant with your other facility, or comparing your grinding unit with the world-class grinding unit, or comparing your cement integrated mill with some other benchmarked industry, are we comparing it on real-time basis? The answer is no today. So we are bringing this experience, very solid and very promising solution, where we are going to collect the data from your existing DCS, and within a week's time, 10 days time, the dashboards will be available for your quick understanding. And not only quick understanding, the baselining of your existing plant can be established, including the CO2 emission levels. And once we do that, what's the next step? Once we collect the data, we know exactly where all there is a potential for energy efficiency, and we'll prepare a report and communicate to the decision makers. And once we agree for further engagement, we are underlining the guaranteed saving plan, either through a CapEx route or through a ESCO route, so that next couple of months or maybe couple of quarters, we will be engaged with the client as a consultant as well as a EPC solution provider, so that ultimately your overall energy consumption as well as his heat required will come down, and that will be guaranteed figures, and we are going to underline that. I spoke about both the models. There can be a traditional way of business. You will be releasing orders for capex nature, where we will be also giving you bank guarantees. And there is a very unique solution, which is whatever you are going to save. And also this digital tool is going to help me to have M&V in place, because measurement and verification is a very key factor when it comes to ESCO as a business. And without ambiguity, when the data is collected on real-time basis, minute by minute basis, there will not be any ambiguity. And we will be going by the data itself. And whatever saving has been committed and whatever has been delivered, this is the delivered saving, we will be taking our pie. And that will be predefined a contract, performance contract from day one itself. These are the few names where we have implemented our EMS solutions. Not only in India, you can see Dangote, you can see a Sharjah Cement, as well as Siam City Cement. So, I mean, of course, we have started from India, and definitely with the experience and the knowledge we have gained from all of you, most of you, we are implementing it into outside country as well. And looking forward for a meaningful question answer session, sir. That's all from my side. Thank you so much.
Yeah, thank you, Sachin, for sharing various energy management solutions suitable for industry as a whole. You have elaborated in details how the energy management services can cover the various aspects of a manufacturing, how we can focus the performance improving KPIs of CPP and cement using the digitalization. So I think this is the need of the hour. We have to have all these things together, how we can use digitalization to improve our performance KPIs. That is going to help, whether it's related to efficiency, whether it's related to reliability, whether it's related to green fuel enhancement. This is going to take place. Thank you, Sachin. Thank you.
Thank you, sir.
So now, at last, not the least, we have Mr. Jagdish Tiwari and Ritesh Sinha from Ultratech Dala location. They will be sharing with us the best practices they have employed in their plant. So welcome, Mr. Jagdish and Mr. Ritesh. Please share your experience, your presentation.
Thank you, sir. Thank you, Vinay Kapil, sir. It is visible, sir?
Yes.
Yeah. Good morning to one and all. Respected Vinay Kapil, sir, all CII team members, and all dignitaries from different units. I am Jagdish Tiwari, and along with Mr. Ritesh Sinha, welcome you all. And we are going to present the best practices which we are employed at our Dala unit. And before that, I thanks to CII for giving us opportunity to showcase our best practices at national level. Now, sir, coming to the content of the presentation, we are going to share our plant configuration, energy consumption overview, green energy, and CPP best practices. We are having, sir, one captive power plant, that is a 27 megawatt captive power plant, and which is having AFBC boiler, BHEL make, and condensing turbine from Siemens make, and generator is TDPS, and we are having DM plant, then DM plant plus RO system, and coal handling and limestone handling system. Coming to the performance, sir, This unit, Dala unit, we have taken over from Jayaprakash Associate Limited in 2017 June. And at that time, auxiliary power of this unit was 12.46% in FY18. Then we have done a lot of improvement and reduced the auxiliary power in FY22 up to 6.48%. That is near about 6.38% reduction we have done in last 4 or 5 years in the front of auxiliary power. And monthly we have achieved less than 5%, which is benchmark in our group units, in Ultratech units. By reducing, apart from Dala unit, we are also leading the projects at our group level. And by previous year, we have reduced 1% auxiliary power consumption at group level. And by reducing the 1% auxiliary power consumption, we have reduced near about 2750 metric ton CO2 per year at business level. So that is contribution towards sustainability. Coming to the heat rate, sir, we have reduced heat rate near about 327 kilocalorie per kWh, and which contributed to reduction in carbon emission. And now current level is our 3041 in FY22 we have achieved, and also we have achieved less than 3000, which is difficult to achieve in AFBC boilers currently, but we have done a lot of modification and done a lot of improvements. By that improvements, we have achieved auxiliary power, we have achieved heat rate and competing with CFBC boilers in front of heat rate in our group units. Now coming to the green energy, sir, we have installed 13 megawatt WHRS power plant, and boilers we have taken from Thermax, and turbine we have taken from Triveni. And now our power cost, CO2 emission reduced by 30-40% because we are using 40% power for our cement production from green energy. And we have recently commissioned this unit in the month of October 21, and with record time in our group units, first time we have commissioned the WHRS boiler in less than 1 year. 11 months, in 11 months we have commissioned the WHRS plants. Coming to the solar power, sir, in front of green energy, we have initiated the installation of solar power plant at 0.5 megawatt, and work is going on, and we have targeted for commission in the month of September 22. Further, it will reduce our CO2 emission, and it will also fulfill the requirement of renewable power obligations. Now coming to the best practices which we have employed at our unit, sir, we have categorized in 6 baskets. First is process optimization, second is technology upgradation, third is green generation, already I have discussed, sir. Then fourth is digitalization, and fifth is innovation, which we have done at our unit to improve our plant performance. And last is alternate fuel. And now process optimization will be shared by Mr. Hitesh Sinha. Before sharing the process optimization best practices, I will share some projects which are doing since during project execution or new project equipment procurement. We are taking intelligent MCC for better monitoring of the energy, and all pumps and fans we have taken all new. We are taking with BFD, screw type air compressor with BFD, energy efficient motors and illumination system we are installed, and new installation we are also considering the same. Replacement of old pump and fans with energy efficient pumps and fans. In phase manner, we are replacing all our old pumps and fans on the basis of ROI with new energy efficient fans. Now Mr. Hitesh Sinha will present the further, sir.
Good morning, sir. This is our first best practices, which is the BFP discharge pressure optimization through our bias logic. In this logic, our BFP discharge pressure will be set to the steam drum pressure plus the set point which will be given to maintain our discharge pressure with controlling our drum level, sir. Through this process, we can optimize our energy about near about 2000 kWh per day, which give a saving of 25 lakh per annum, sir. In our this is our second best practices, which is the reduction in the FD fan power. which is a higher power consuming equipment in our boiler, which we can optimize through our process optimization, and we can able to reduce our power consumption in every fan by reducing its wind box pressure, which is earlier running at 750 WC, and now we are operating at 530 WC, through which we can able to save 1500 kWh per day, and which resulted of saving of 18.11 lakh per annum, sir. Our third best practice is replacement of ACC fan blade with epoxy coating AFA FRP blades, which is lighter in weight and is high energy efficient, through which we can able to achieve the saving of 1140 kWh per day, which resulted saving of 17.38 lakh per annum, sir. This is one of the innovative project which we have done is a rerouting of the line of LP heater drains. Earlier, LP heater drain was connected to our hot well and through hot well pump, it will be transferred to our CRT tank, in which we have directly install a line which is from the LP heater to CRT, through which we can save the running of our hot well pump, and which can give the energy saving of 60 kilowatt per day, and resulted 6.65 lakh per annum saving. Fifth one is the optimization of ACC discharge pressure, which is also for the process optimization. We can through the brainstorming we can optimize where the excess pressure of water, and we can reduce it and throttle according to maintaining our related parameters and temperatures, and through which we can earlier running 4.5 kg of discharge pressure, and now we are optimize it at 2.5 kg per centimeter square of discharge pressure, which can give saving of 600 kWh, and in monitoring saving is 7.24 lakhs per annum, sir. This is also the process optimization in which we can reduce our instrument compressor loading unloading pressure set point. Earlier it was 5.2 kg, and now we are operating it 4.2 kg per centimeter square, which can give also saving of 1300 kWh, and with the 15.69 lakh in annual savings. This is innovation project technology upgradation product, in which we can change our old cooling tower fan with fanless cooling tower, in which which can install with cost of 17.68, and we can give a power saving of 16 lakh per day. Actually, we have proposed for we have changes in the existing cooling tower, which can be cost of 13 lakhs. So we are change it with the new technology with fanless cooling tower, which can give a saving of 17.3 lakh instead of repairing old one, and the cost saving for the energy saving we can 4.9 lakh. This is the process optimization in which
this is a process optimization project which we have taken to reduce our LOI from the boiler. Basically, in CFBC and AFBC difference is only LOI. If LOI in AFBC LOI is more, then that's why we are getting low efficiency. So what we did, sir, our earlier LOI was 5.5% with indigenous coal of 4000 kilocalorie per kg. So we have taken a target to reduction this LOI up to less than 3%. We have done a lot of experiment on the front of LOI, and we have optimized the airflow, oxygen less than 5%, and replaced the coal nozzle, and also reduced its height to improve the combustion efficiency, maintain the coal size by monitoring shift wise, and again reduce the furnace draft, and also reduce the PA fan discharge pressure, which is used for carrying the coal in the bed. By reduction of this, we have achieved near 2.7% LOI, and we have reduced near about 2%, and which gives the efficiency improvement in boiler by 1%, and reduce the 40 kilocalorie heat per kWh heat rate of the plant, and saving was near about 60 lakhs per year. By doing this, we have also able to use the 100% fly ash in cement mill. Basically, their requirement is less than 5% LOI. That's why we have taken a task, and done. Our team has done a very good job in this front, and reduced the LOI less than 3%. Now coming to the one another modification, sir. Due to spray system, our boiler feed pump power was more. What we did, we have done collaboration with Thermax, and in shutdown, Thermax engineer visited the site, and they have proposed one modification by changing the area of spray nozzle. Basically, we have made the holes more dia and added 2-3 holes in the spray nozzle, and by this we have reduced the we have increased the spray consumption, but reduced pressure. So by this we have saved near about 20 kWh per hour in boiler feed pump, and saving is near about 5.34 lakhs per year. And we have also, in front of alternate fuel, we have used rice husk in the boiler. Earlier, we are mixing the rice husk with coal and taking in bunker through coal, and we have used near about 5 to 10% in previous year. This year, since we have linkage coal, our cost is less, and rice husk now cost is higher, so we have stopped the rice husk in the boiler due to our cost high cost, and started using in the cement plant. Now, sir, we have done one more process optimization. Basically, our turbine is designed for 85 kg per centimeter square pressure, and temperature is 510. Desk operators are maintaining 85. When they are maintaining 85, then average is coming 82, 83. What we did, we have given them to maintain in between 85 to 87 and temperature 510 to 515. By that, we are able to maintain the average 24 hours pressure temperature at our design level. And we have also given appreciation to our monthly appreciation to our desk operators, which in shift wise. If they are operating at design level, then we are awarding them. So their motivation level will be maintained. And by this, we have reduced near about 10 to 12 kilocalorie per kWh in the heat rate front. Coming to the digitalization front, sir, we have introduced the boiler reliability project, and we have collaborated with the Exact Space, that is one startup. By this, we are measuring our key parameters, and the key parameters, and they are giving predictions to us in which parameter you are deviating at, in like superheater spray flow path. There is problem in superheater spray flow, if that is increasing or decreasing. Then APH exit flue gas temperature they are monitoring, PF and fans mechanical health and boiler feed pump mechanical health they are monitoring, and they are also monitoring the boiler before shutdown. They are monitoring how your boiler is operating. By this, they are giving us reports, and on the basis of report we are working, and in shutdown we are doing modifications so that our reliability will be maintained. And apart from that, we are having knowledge manager and energy management system. In knowledge manager, we are monitoring the R parameter accordingly. We are tuning the PID, and this is the glimpses of knowledge management system. Now coming to the way forward, sir. Further, we have targeted our heat rate and if auxiliary power less than 2,900 kilocalorie per kWh and auxiliary power less than 5 on yearly basis. For that, we have taken capex and projects, sir. We have taken capex of energy efficient forced out fan installation in boiler, and we have also, sir, done designing of one new project, that is for connecting of TPP steam line with WHRS steam line. In between, we are installing micro turbine, which will reduce the apart from PRDS. We are not going to install the PRDS. We are going to install the micro turbine that will reduce the pressure and temperature of the steam, and that less pressure temperature steam directly we can feed to the WHRS line, sir. Now we are also approved capex for replacement of turbine with enhanced capacity. Our present turbine is 27 megawatt, and we have taken capex of 30 megawatt turbine that will install at same foundation, and that will give us saving of near about in steam consumption 0.1 kg per kWh reduction in steam consumption. That will reduce near about 80 kilocalorie per kWh. And also interconnection, we have taken one initiative at our group level, sir. Now looking to the green energy, we have installed all the units in WHRS project. So our one turbine is normally standby at our all plants. What we are doing, sir, we are doing interconnection of ACCs. By interconnection, we are getting better vacuum, and by better vacuum, we are getting less heat rate of turbine, and also reduction in auxiliary power consumption. So these initiatives, we are reducing the carbon footprint under the umbrella of sustainability, and this is all from our side, sir. Thank you to CCII. Thank you, Binay Kapil, sir.
Thank you, Jagdish Tiwari ji and Ritesh, for sharing your journey towards excelling in heat rate and auxiliary consumption at your CPP. You have indicated the various action that you have taken to achieve the auxiliary consumption in the range of like 6.5% on annual basis, and on monthly basis also it was around 5%. Similarly, in case of AFBC boiler, you have also achieved a very good heat rate. So you have shared the various action that you have taken to improve the CPP KPIs related to efficiency through various process optimization, with the digitalization, with a few innovative projects, few energy efficient replacement that you have done, and further you have planning. So I hope whatever you have shared that will give very good ideas to the various participants. So thank you, Mr. Jagdish, Mr. Ritesh, for sharing your journey towards excellence in power plant heat rate and auxiliary consumption. So now
Thank you, sir.
yeah, thank you. So now we are about to conclude this session. Before that, we would certain question have come from participants. So the first question is for Mr. Jagdish Tiwari. The first question is to Mr. Nagaraj. One participant has asked in the existing units, what has been the maximum utilization of biomass in percentage till date?
And in the point of the maximum percentage, we are utilizing up to 70% of biomass in my CFBC boiler.
Okay. So biomass means basically rice gas you are using.
Yes, only using the rice gas. And some very less quantity of the bagasse also we are using, but it's not a much percentage. It is maybe a 0.5 or 1% only.
17% is the highest percent that you have achieved on daily basis or monthly basis?
Pardon, sir, your voice is not clear to me.
17% is a daily basis or
Monthly basis.
Monthly.
Yes, sir.
Oh, good. Second question is for Mr. Jagdish Tiwari. During this coal crisis, whether alternative fuel uses has impacted. I think you have already shared that because of higher alternative fuel prices or rice gas prices, you have already stopped using rice gas. Is it so, Mr. Jagdish?
Yes, sir. We have stopped in boiler, sir. Now we are started using our kiln, sir.
Okay.
As alternate fuel, sir.
Okay. Okay. So this is on. So I have received only 2 questions from participant. There is no more question. Team CI, have you received any other question?
Sir, one more question is there, but I think that is for Mr. Sachin Mane. But I think that is already it was taken. The question is like, what is the process followed or criterion for the conversion of traditional existing setup to IoT enabled system? Are there any limitations? So I think that is already covered. Still, if you can add few points.
So the tool which is available with us do not restrict only to DCS connectivity. Even if whatever old is your plant, even if there is a necessity of positioning few controller, we are ready with that, and we have more than 95 to 97% compatibility of all the, I mean, worldwide DCS manufacturers or PLC, suppliers, or even the marriage of existing system, can be integrated with these controllers. So I think that should not be a challenge. Of course, I know there will be few plants where the connectivity can be an issue, but our solution will take care of that. So the starting point always remains with the data collection. For whatever reason, if few places you are not measuring the data, we can position the controller. I mean, that is not an issue. Even if required, metering can be also done. But I know, as much as I know, most of the cement plant, including the grinding units, all necessary data is coming to your DCS. So for cement industry, it should not be an issue.
Right. That is it, sir. These were the questions.
Yeah.
So, sir, we'll close the session, sir, then.
Yes.
Information. Okay.
Yeah.
Thank you all. Thank you, Mr. Nagaraj Prasad, Mr. Sachin Mani, and Mr. Jagdish Tiwari, and Mr. Ritesh Sinha for accepting our invite and sharing your presentation and technologies, the implementations what you have done in your plans. So these best practices definitely will be helpful to many of our participants who have joined today. So thank you all, and thank you, Vinay Kapil sir, for joining us and leading the session. So we'll close the session now, sir. Our next session in the track C will be starting at 11:15. Track A and B still sessions are ongoing, so participants are requested to join there. Thank you, sir.
Thank you.
Thank you.
Thank you.
Thank you, everyone.
Thank you.